Assalamu alaikum. Now, today we are solving this question. This is from 2016, paper 42, question number 5. Now, this is sent by one of my students, and today we are solving this question. Okay, so let's just read the question. In this question, they're saying that cadmium ion form complexes with primary amines and 1,2-diaminoethane. So, this is cadmium ion, CD2 plus, and it can form complex with methylamine and 1,2-diaminoethane. Right, so we have these two equations here, equilibrium 1, equilibrium 2, and they're saying that in first part they're saying write an expression for the stability constant K stab for equilibrium 1. So we have to write the equation of K stab for equilibrium 1. So this is just simple question. So K stab is product upon reactant. It is an application of Kc. So the products here are CD, CH3, NH2, 4, 2 plus upon concentration of CD2 plus, concentration of CH3, NH2. So this is the ligand power 4. So now this is the equation of K stab. And in the next part, they're saying write the unit as well. So we have to write the unit. So the units of concentrations are the concentration of the unit of concentration is moles per dm cube. So in we have moles per dm cube upon moles per dm cube power 4. So this would be moles per dm cube power 5. This moles per dm cube would be cancelled by this, and we're left with 4. So the unit would be mole minus 4 dm 12. All right. Now in the next part, they're saying that cadmium ions are poisonous and need to be removed from some water supplies. All right, they are poisonous and we have to remove them from water supply. So this is often done by adding a complexing agent. Now this is a complexing agent, right? Add this methylamine in cadmium, it would form this complex, and in this way we can remove cadmium. So this is often done by adding a complexing agent. In a sample of groundwater, the concentration of cadmium ion is 1 into 10 power minus 4 moles per dm cube. So this is initial concentration, right? And number of moles would be same because this is 1 moles per dm cube. Now calculate the concentration of methylamine. Calculate the concentration of methylamine needed to reduce the concentration of cadmium ion in this dilute solution by a factor of 1000. All right, so we have to reduce the concentration of methylamine. The actual concentration of methylamine was 1 into 10 raised to power minus 4 mentioned here, and they're saying now reduce this concentration by a factor of 1000. So the concentration would become 1 into 10 raised to power minus 7. If we reduce it by a factor of 1000, it would become 1 into 10 power minus 4, right? So this is the concentration of the cadmium ion at start, and this is the concentration at equilibrium, and we need to calculate the concentration of methylamine needed to convert this concentration into this one, right? So let's just write the expression first. CD2 plus CH3 NH2 4 moles would form CD NH3, so CH3 NH2 4 2 plus, right? And we have K stab, the value of K stab as well. This is 3.6 into 10 power minus 10 power 6, right? So the initial moles that we have is 1 into 10 raised to power minus 4. These are the moles of cadmium ions, right? And we need to calculate the concentration of methyl or moles of methylamine. Need to convert this concentration or this moles into, at equilibrium, the concentration of cadmium ion would be 1 into 10 raised to power minus 7, right? This is at equilibrium. So we need to calculate the concentration of methylamine, which would convert this moles into this one. So we just assume that this is X, right? Let's just assume it is X, and at the start the concentration of complexes or the moles of complexes 0. Right now at equilibrium, because the molar ratio of cadmium ion and complex is 1:1, right? So we can just simply say that the amount of moles consumed the amount of moles of cadmium ion consumed in reaching at equilibrium would be the amount of moles of complex formed at equilibrium, right? So let's just calculate how much cadmium ion is being consumed. This is the moles at the start and this is the moles at equilibrium. So the moles consumed would be 1 into 10 power minus 7, 1 into 10 power minus 4 minus 1 into 10 power minus 7. We just simply subtracted it from the initial moles, right? So this is initial moles at equilibrium. So the moles consumed would be 9.9 into 10 power minus 5, right? So this is the moles of cadmium consumed in reaching equilibrium. Moles of cadmium consumed. And obviously the same moles would be produced for this complex because the ratio is 1 to 1. So the moles of complex formed at equilibrium would be 9.9 into 10 power minus 5. Now the last thing we need to calculate is the amount of or the moles of methylamine at equilibrium, right? We said that initial moles were X and cadmium is consumed 9.9 into 10 power minus 5. The ratio of cadmium and methylamine is 1:4. So to calculate the moles of methylamine at equilibrium, let's just multiply this value by 4, right? And this would be 0.0004. So this is the moles of methylamine consumed. Moles of methylamine consumed. Moles of methylamine CH3NH2 consumed. And in the start we have this X moles. So the moles at equilibrium would be X minus 0.0004. Now we have the moles of all the three substances present at equilibrium, and we can just simply put it in the expression of K stab. We have the value of K stab as well. So the value of K stab is 3.6 into 10 raised to power 6 is equals to the concentration of complex is 9.9 into 10 raised to power minus 5, right? This 9.9 into 10 power minus 5 upon the we are using this expression, this one here, right? So the concentration of complex upon concentration of the cadmium ion and the ligand methylamine. So the concentration of cadmium at equilibrium is 1 into 10 raised to power minus 7 into the concentration of methylamine is y minus 0.0004 power 4. And sorry, not y, it is x. X minus 0.004. All right, let's just solve this one and calculate the value of x, and that would be our answer. So this would become x minus 0.0004 power 4 is equals to 9.9 into 10 power minus 5 upon 1 into 10 power minus 7 into 3.6 into 10 raised to power 6. And by solving this one here, we get the answer x minus 0.0004 power 4 is equals to, this is 1 point or 2.75 into 10 power minus 4. All right, and to calculate the value of x, we will take we will take fourth root. All right, because we have power 4, to take fourth root on both sides, take fourth root on both sides. It would become x minus 0.0004 is equals to 1.28 into 10 raised 1.287754 into 10 power minus 1, and the answer would be 0.129. Right, this is the final answer. All right.